Hello students, Java programming course. The current chapter we are discussing packages of Unit 4. The topic is, and the chapter part we need to discuss is packages in Java Standard Edition 8. And this is video 5. And these are the topics to be covered in today's video. Class math, wrapper classes, autoboxing and auto unboxing. First one, class math. And this is the class generally used for doing arithmetic operations with number related things, right? So the math class contains all the floating point functions. That's why the default type for this class variables or instance variable or type returns methods, maybe most of the times we consider that double value. And these floating point functions that are used for geometric and trigonometric functions, and as well as several general purpose methods also available in this math class. This math class belongs to java.lang.math package, and this is a class and a part of this java.lang package. And yesterday we started the topic package, the built-in package called java.lang, and this is one of the class. And this math defines two double constants about the exponential, approximately value 2.72, and pi in the approximately the value 3.14. As this one math class, the trigonometric functions, it supports for trigonometric functions, and the methods for these trigonometric functions accept a double parameter. As I told you, most of the time this math by default it takes floating point values and functions type. So the default parameter for these methods is double parameter. And specifically to this trigonometric functions, generally it takes argument as a double parameter. As you observe here, method trigonometric point of view, sine, cosine, tan, and it takes that parameter value and angle in radians. It takes this input as an argument specifically to these trigonometric functions, and it returns the result of their respective trigonometric function, right? For example, if you take sine function, trigonometric function, it returns the sine of angle specified by the argument in radians. So like this, sine, cos, tan, these are supportive trigonometric functions. And when it is these type of functions defined in our general programs, you can directly invoke these classes in our Java programs, because this java.lang is a built-in and widely used package in all the programs of Java language. And whereas coming to some other methods for the same trigonometric point of view, and this is taking the nothing but the previous one, it is discussed some of the values taking input parameter as a angle in radians, but these set of functions takes the result of trigonometric function, and returns in radians, It takes the result of the trigonometric function as we did the previous methods, and it takes input and gives that radians example, right? That nothing but radians, nothing but the angle that would produce that result. They are inverse of their non or companions, right? Non or companions. From the previous one here it is. It takes one parameter and based on that it returns the angle in radians with respect to this sine function or cos function or tan function, and these are some inverse to those functions, right? And another set of methods that compute hyperbolic of the sine, cosine, and tangent of angles. So these are functions for representing that hyperbolic format of this function, sine h, cos h, tan h. That is the representation, right? And these are the set of methods of this math class supports in trigonometric calculations. And next one, exponential functions. And we know in our general programs we use some uh, exponential values and log values and base values. Sometimes we use this power function to taking that value y, rise it to x, like that. And different square root also, be aware of this one, square root function. It returns square root of some argument passed to this method. These exponential methods based on some set of these set of methods will built-in methods available in this class. And another set of functions in this class map is of this package java.lang, rounding functions. So three types of functions, right? First one, trigonometric, exponential, and rounding functions. This math class defines several methods that provide various types of rounding operations. Rounding the value. When you take absolute values like that, and they are shown in table, and notice that there are two functions related to this QLP. What it means? Method name is QLP. And in this context, QLP stands for units in the last place. Units in the last place. Last place. When you take the number in form of digits, last digit, ones digit, tens digit, hundreds digit, like that. It ULP stands for units in the last place, and based on that, it identifies or indicates the distance between a value and the next higher value in the set or equivalent list of elements. Like it can be used to help assess the accuracy of the result. Based on this UPL method, you can find out the accuracy among the given set of elements or comparing the two values, which one is the accurate value. Based on that, the units in the last place based on what is the last digit value and not rounding off, based on that it can apply. These are the methods features added recently, right? And we will see some more things, some more important points about these functions. And coming to here, these are the some list of methods given in this math class related to this rounding point of view, rounding the values. So absolute value for integer, long, float, double, and seal value, seal and float. And you are aware of these two words, and most of the mathematical operations in our programming first year, second year, we will do programs on these values, seal the value and float value. Maximum value for integer, long, float. When you use set of values, it finds the maximum amount to given x and y, like that, and minimum of like. So these are some rounding functions available in this math class. We can include all these in our classes by instancing or invoking this class name along with the instance. We can use some all these methods in our language, in our programs automatically. And these are some set of values, like another set. Next after next up, print. Print means it nearest in value to argument. So when you give the argument to this function, it returns the integer nearest to the value of the value passed to this parameter as parameter to this function, right? Round, and I told you that ULP returns unit last place. right? Unit of last place. And some example programs. I will take max minimum type. The Java math class has many methods that allows you perform mathematical tasks on numbers. Example math.max. This is the max is a method and it expects two parameters. Either it may be integer, double, float, you can pass like this. And it returns what is the maximum of these two numbers. The math.max method can be used to find the highest value of x and y. Example math.max 5, 10. Among these two, which one is the highest value? That value is returned by this method. And minimum also the same. It returns the minimum value or lowest value of x and y. And square root function in math.square of x method, when we invoke this method using this class name and importing the Java language dot, importing or not importing, it doesn't matter because it is predefined class imported into all our Java programs. So this is example given. So I will show you an example program for this class math for understanding you how to invoke these methods of this math class. So coming to this class, yeah, it is. So the same, I'm invoking this square root function, square root method of this math class into my Java program for finding square root of my given value. Okay, then go to command prompt. So here it is my current directory. Then go and what is the class name? ABC and Java. As it is compiled, execute Java space ABC. It gives 8. Square root of 64, it is 8. Got it? This is the one. Next one, wrapper classes. And it is the concept related to primitive type available in Java about data types. So wrapper class provides a way to use primitive data types, integer, boolean, character, float, like that, as objects. Till now we define these things as a variables in our program, but in Java it provides you to define those as an objects of some wrapper classes. So right, the table below shows you the primitive type and equivalent wrapper classes. Wrapper classes, this is the byte, short, int, long, float, double, boolean, char, primitive data types. All these are primitive data types. And whereas coming to this corresponding wrapper classes, so byte is a data type here and byte is a class here. This one byte is a wrapper class, and using this class we can create an object of byte and we can use that value in our operations as an object instance or the value of that object, right? The same way here, if you observe that the wrapper classes and normal primitive data types differences, it is starting with uppercase letters and this one is starting with normal keywords. Consider one example, class main1. Inside of main function, I have taken this wrapper class integer to declare one integer variable and initialize the value 5 as like double value, and it can take in double value to this double object. These are now objects, not variables. Consider these as a objects of these classes like a character, and simply you are taking these into displaying this one, right? So it displays simply display 5.5.99 and 8. Okay, and go to execution part of this one. I will show you main1. Yeah, this is the class program. We have taken 3 wrapper classes, integer, double, and character, and go to the console. What is the class name? Java C space main1 dot Java. Yeah, it is compiled. Java space main1. So these are the values displayed. integer value, double value, character value. Got it? Then go to, and here we have some set of methods of these wrapper classes, and we can invoke all these methods with any wrapper object, right? So here these following methods are used to get the value associated with the corresponding wrapper object. So int value, byte value. If you observe here, this is specifying the type and we are accessing that value. The same way here also, right? So here it is the program main2 inside of this main function. I have taken the same three values, but now I'm accessing these wrapper class object values to the this function corresponding of these corresponding functions. You can call my int value. So it is an integer wrapper class object. So we can use this method to access that value. The same way double value, character wrapper object, character function. So go to execution part. That's this one. The same program I have taken into this file. The file name is main2.java. Command prompt javac main2.java file and executed. The same thing, the same values are this accessed through these functions of wrapper classes. Okay. Next one. Another useful method is to toString. This method is already we are discussing in our last video also. toString for better understanding you about the values we can access in form of strings using this method. And it is also a function available in object class also. That's why you can invoke this method anywhere of your programs without any instantiations. You can call this through the objects of the classes that are like wrapper classes, and in the previous also we access these methods, right? In which it is convert wrapper objects to strings. Wrapper object is converted into strings by using this toStrings method. So in this example program, we convert an integer to a string and use the length method of the string class to output the length of the string here. So consider this program name, class name is main3. Inside of this main method, I have taken one integer value and initialized this integer wrapper class object and initialized it with 100 integer value. So I have taken another string object like my int.toString. So to initialize this my string object of this class, so I have called just here toString function using this wrapper object. So it automatically converts this wrapper object value into string and assign to that to my string. So I'm just displaying the length of this my string object belongs to the string class by calling the length function. Right? It is a valid one, and the value is initialized to this my wrapper object is 100 and convert that into string. The length of the string is 3. That is the output. So see here, this is the same content we have stored in this main3.java file. You go to console command prompt. Yes, it is. javac main3.java is my file name. Successfully completed, successfully compiled, and execution also done. Right? All these are valid statements. Next one, Autoboxing and auto unboxing. This is the features added to Java, right, from JDK5, right, from the beginning of JDK5 Java added two more important features of this auto boxing and auto unboxing. The, the automatic adoption of primitive data types into its corresponding wrapper type is known as boxing, right? Right now we are taking wrapper objects to organize this data type, primitive data types in our programs. The automatic adoption of these types into wrapper type is called boxing. This is the feature added to Java from JDK5. And the reverse operation is known as unboxing. That it means it is taking adoption of these primitive types into wrapper object, and wrapper object to primitive is unboxing operation, right? One advantage of using these features is that programmers do not require, see this one is important, do not require to convert between primitives and wrappers manually. It automatically, that's why the definition is saying that the automatic adoption of primitive data type into its corresponding. Its corresponding means when you take this primitive type as an integer, it converts that into a integer wrapper type object. So do not require to convert between primitives and wrappers manually, and hence less coding is needed. That is the most primary advantage by considering this boxing and unboxing, right? Coming to the example point of view, before that one, just go through some more important details encapsulated and extracted. Autoboxing is the process by which a primitive type is automatically encapsulated. The same process here it is given, but the process of doing this one, what is that one? Primitive type to wrapper type. The concept is called encapsulated. That it means of meaning that because we are boxing this into a process converting automatically from primitive type to wrapper type, right? In the same way, there is no need to construct an object explicitly. Remember this one. This process of overhead is reduced by using this auto boxing and auto unboxing. So in the previous ones, you need to create an object explicitly to convert that into that primitive type to wrapper type. We need to create an object, construct an object there, but here it is no need. This auto boxing is the process by which the value of box object is automatically extracted. So this is called process of unboxing. So it is also a process of converting that boxed object value into wrapper type to primitive type. So when the program it requires value. So boxing the primitive data type value as a wrapper object, and when it is required the value for processing, it unboxes nothing but converting that wrapper object type to primitive type. Generally, this type of process occurs in expressions, and this auto boxing unboxing concept helps most in expressions evaluations or expressions uh, coding in the point of solutions, right? In general, auto unboxing takes place whenever a conversion into one object or from an object is required, right? Generally, we take these processes when we actually require to conversion, right? An object to the form of an object is required. We know that primitive type assigning a value to a wrapper corresponding that relevant wrapper object, right? So then only in that situation we require this boxing and unboxing to get system performance improved in rate and lessen the code of required. It applies to expressions. Within an expression, a numeric object is automatically unboxed. The numeric object is automatically unboxed. So here the outcome of this object is automatically reboxed when necessary. So see the same point in example program. Here is a simple program showing the working of auto boxing and auto unboxing. So consider my class name as main4, and inside of this main function of this class, I have declared one wrapper object like integer IOB equal to 60. And I have taken another that it is IOB equal to 2. Right? Both are IOB, IOB2. Both are wrapper objects. So when you assign a value to this one, it completely takes that into Autoboxing concept. So when you assign the integer of this wrapper object directly, in the previous programs we defined one wrapper object and assigned a value to that one, or maybe taking one integer value and assigning a value to this one like that. So Autoboxing concept is this one. When we assign this wrapper object value to any integer primitive data type variables, then that's a concept called auto unboxing, right? So when it is actually required, right? So when you are displaying the values like we have taken first 60 value, and that 60 value is assigned to I. And we are displaying that I value along with I board. So both are 60 now, right? 60, 60, first output. When we are performing operation, so that's why I have taken another object, wrapper object IOB of this integer, IOB2 equal to IOB plus IOB by 3. So when you are taking this type of operation applying on this wrapper objects, you need to unbox that value, that nothing but I. So it takes I value, object is nothing but 60 here, 60 plus 60 by 3. So 60 by 3 is 20, 60 plus 20, 80. So 80 value is again auto box into this IOB2. Auto box, auto unbox. There is nothing to taking complexity here. We are just taking that value, automatically converting that integer normal primitive data value into the wrapper object is the process of auto boxing. Just remember this one, these points. When it is required, simply explain these concepts with that this type of simple programs, like right. After that, we are displaying I value and IOB value, IOB2. So here 60 and 80. So coming to the same example program. So this is the program taken as it is here in main class 4. Go to console for executing of this one as it is. Yes, Java C main4.java. Compile it, successfully compiled. Execute this one as it is, got the code, right? As it is, boxing and auto unboxing concept. So these are the differences, and most of the examples covered from this website w3schools.com. Thank you.